On a Dutch forum there was a question about running a Pendelzug or a shuttle train without using computer control. Ulenbrock has a product that can do this, but it needs infrared sensors, and I thought it would be much more fun and cheaper to build one ourselves. We can easily connect an Arduino to Loconet and write some code that receives the occupancy detection messages from Loconet for the brake and stop sections, and in turn responds with Loconet control messages for the locomotive. Now, to make programming later on much easier, let's just draw this out. First, we'll add a train track. We'll add station A, station B, and in station A we will add a stop and a brake section, and we'll do the same for station B. Next, we will add a locomotive, and we have to keep track of where the locomotive is. So let's just say that when the locomotive is in station A, our status or state will be status 1. When the locomotive starts moving from station A to station B, we will change the status to status 2. This will mean that in stage 2 the locomotive is running between station A and station B. But as soon as the locomotive hits the brake section in station B, the status will change to 3. In state 3 we will decelerate the locomotive so it won't stop abruptly in the station later on. The locomotive will keep on rolling into the station at a slow pace, and once it hits the stop section in station B, the status will change to 4 and we will hit the brakes and come to a full stop. Now we'll just wait for a while so the passengers can get off the train, new passengers can board the train, and we'll reverse the locomotive. And after that we go from station B to A in reverse order. When we roll out of station B, we will change the status to 5, and when we hit the brake section in station A, we will change the status to 6. The locomotive will start braking again, it will roll into station A at a steady pace, and we will hit the stop section in station A. We will change the state to 1 and we can start from the top again. Now we can be in the situation that we will be powering up a model train track and the locomotive will not be in station A or station B. In this situation we can't just start running the locomotive. We will have to manually drive the locomotive to station A or station B. This status will be called status 0. And in state 0, automatic operations will not be available. From the model railroading with Arduino Loconet Github, I have loaded the example file for the Loconet monitor. I've uploaded it to my Loconet Arduino board, and I will make a video later on about this Loconet board. Because I don't have a model railway track available at the moment, I've made a small demo board. By connecting a couple of switches and buttons to an old S88 occupancy and feedback module, I can simulate a model rail layout. Let's check if the buttons and switches work. Stop for station A, the brake for station A run and a stop button, the brake sensor for station B and the stop sensor for station B. For this project I have written some code, but I had to do a little bit of hacking because the S88 connected to the Unibrock IntelliBox will on a power up or on a go command not send out its status. Fortunately, Unibrock has a Loconet command that we can use. It's not documented, but I could find it on the internet and write a small subroutine. I am using feedback sensors 1 to 16, and those are requested from the IntelliBox. If you want to use sensors 17 to 32 or 33 to 84, you will have to change this bit of code. By changing it, you will request different feedback sensors from the IntelliBox. You will find this sketch on my Github, and I'll put the links down below. Now, let's compile and upload and see if it works. At the moment, station A and station B are not occupied. Let's make sure that they are both in the off position, and we'll switch on the power to the track. The Arduino will detect that the train is not in any of the stations. Next, we will simulate that the train will be in station A. We will see that the wait timer will start counting down, and when it reaches 0 seconds, the train will start moving. When it is detected by its own brake section, it will ignore the message. And brake section B will make it decelerate until it is detected by the stop section, and it will stop. The countdown timer will start again, counting down, and when it reaches 0, we will be traveling from station B back to station A. Again, we will ignore our own station's feedback, and when we hit the brake section in station A, we will start decelerating and come to a full stop in station A, and the whole process will start from the top again. Now that's it for this video. If you liked this video, like, comment or subscribe.